Welcome to the online version of the 2019 SKYWARN class. My name is Jason Godwin. I'm one of the meteorologists with the National Weather Service in Fort Worth, and I'll be leading this online course. You may recognize my voice if you have gone to some of our classes this past spring, as I did teach a few of them. So if this is a refresher for you, welcome back, and if this is the first time going through one of these for you, welcome to the class. Before we continue, I do have to go through a couple of disclaimers. The first is that any of the images and photographs used in this course are used with the permission of their original creator, and none of these images can be used without the express written consent of the original source. Also, no certificate of attendance is being offered for this online version, as this is intended to be a refresher and is not a substitute for the in-person classes. We have wrapped up our in-person classes for 2019, but if you're interested in attending one, we should be releasing our 2020 SKYWARN schedule sometime in November or December of this year. So we will be doing them again next winter and spring, so just stand by for that. So why do we do SKYWARN? We do these classes every year, going to all 46 of our counties, teaching these classes, and why do we do it? We have a lot of remote sensing methods, such as our new GOES 16 satellite, which even has lightning detection capabilities. We have radar, we have surface observing systems, weather balloons, so on. And with all these fancy tools, we still cannot see what's happening on the ground. So that's why we need SKYWARN, is for ground truth, to tell us really how big is the hail that's falling, or is there even hail falling? Is there a tornado present? Is there a wall cloud? What kind of winds are going on at the surface? Doppler radar can measure winds, but it's usually looking several thousand feet above the ground. And so we need ground truth reports to tell us what's actually going on at the surface, where we really care about what's happening. And just a couple of quick definitions to get out of the way. A severe thunderstorm warning is defined, or a severe thunderstorm I should say, is defined as any thunderstorm that is producing either 1-inch diameter hail, it's about the size of quarters, and or 58 mile/hour winds. If that seems like kind of an arbitrary number, that's 50 knots. Tornado warning is pretty straightforward, a tornado. So going back to this issue of ground truth, the star right there in the north side of Fort Worth, that's where our office is located, and this map represents our area of responsibility. We're responsible for 46 counties, spanning from the Red River to Fort Hood, from Eastland all the way over to Canton and Paris. So it's a lot of real estate we're responsible for, and we do have a variety of radars across this, but again, this goes back to the issue of ground truth. Our radars cannot confirm what's going on the ground, so that's why we need spotters to serve as our eyes in the field. So the goals of a SKYWARN spotter are first and foremost to remain safe at all times. No report is worth putting yourself or others in danger or creating additional hazards or issues for first responders. But we need you to serve as the eyes on the ground for both us, the National Weather Service, and your local emergency management, and to stay in communication with your team and the National Weather Service. The goals of this class are going to be to train you on how to identify potentially hazardous weather, determine what the criteria are for reporting severe weather, some methods of how to report severe weather, and then of course some safety tips. So what do we need you to report? What is our wish list? Tornadoes are signs that one may be developing. This includes things like a funnel cloud, strongly rotating wall clouds. Flash flooding, this is one that's often overlooked but is very important to our mission. And specifically, we're looking for rapidly rising water in areas that do not typically flood. Hail that's larger than 3/4 of an inch in diameter, that's penny sized. And then damaging winds. Any damage caused by thunderstorm wind gusts or measured winds of more than 50 miles per hour. And I'll go into more detail for these as we go through the class. So what do we need to know when you're reporting severe weather to us? Obviously, we need the type of report. What are you reporting? We need the time of the event. When did it occur? Is this occurring now or was it earlier? Delayed reports are certainly okay. The location of the event, where did it occur, and be specific but not overly specific. Assume that you know more about the location than we do. A lot of us are from North Texas, a lot of us aren't. So, you know, something like 5 miles north of Glen Rose, or I'm at 35W and North Tarrant Parkway. Something like that is a good way of describing the location. How did you come up with this report? Is it something you measured, or is it estimated? Did you measure a 60 mile per hour wind gust, or are you estimating that the winds are about 60 miles per hour? And then the magnitude, which is just a fancy word for how bad is it? Is there any damage? Is there injuries, etc.? So a word on spotter activation. Some group spotters, which serve ARES, RACES, law enforcement, fire departments, etc., are activated by the local officials or through the National Weather Service. However, most people going through this class will probably fall into this category of individual spotters, which can self-activate anytime hazardous weather is or may soon threaten your area. You can watch for a watch or warning being issued for your location, and then utilize any of the various methods discussed in this class for reporting the severe weather back to us. But of course, reports are appreciated any time you have them, regardless of any formal activation. You don't have to wait for us or your local officials to activate you. If you have hazardous weather that needs reporting, by all means report it. So we'll first go through tornadoes in here. Of course, tornadoes are probably one of the more significant, life-threatening, destructive things in our area, so obviously something of paramount concern to us. So what is the definition of a tornado? Because it is something specific here. It's a violently rotating column of air that is in contact with the ground and in contact with the parent thunderstorm. If we look at this picture to the right here, this is a tornado associated with a thunderstorm near Dodge City, Kansas, taken by one of our forecasters here. If you look, it doesn't look like the funnel is in contact with the ground completely. But look underneath the thunderstorm, you can see a funnel right here, pretty well defined, nice smooth funnel. And if you look immediately underneath the funnel, you see some dust and debris getting kicked up. So the column of air is in contact with both the ground and the parent thunderstorm. So the funnel does not have to be all the way to the ground. All the funnel actually is just cloud condensation. It's just water vapor. It's condensed into cloud because of the low pressure in the tornado. But the column of air obviously invisible, is the only thing that actually has to be in contact with the ground for it to be formally considered a tornado. So if you ever see a funnel like this, look towards the ground underneath it to confirm or not confirm if it's on the ground or not. Then there's wall clouds. A wall cloud is going to be a prominent feature that's within the updraft portion of the thunderstorm directly beneath the mesocyclone. Most tornadoes are going to occur underneath the wall cloud. And if the wall cloud is rotating, that will indicate that the tornado potential is increasing. So this picture on the right is a really good example of one. This is a supercell thunderstorm here with a rotating updraft in it. And then the wall cloud is this feature that's indicated by the box underneath. And like I said, it's usually going to be something very prominent. It's not just some small piece of cloud, or the term lowering gets used a lot. It's, again, something very prominent that will jump out at you like this. Then there's funnel clouds. Funnel clouds can be found underneath the wall cloud and is not in contact with the ground yet. If it's in contact with the ground, it's a tornado. And if the funnel cloud is rotating, the tornado potential is increasing. So this is actually a funnel cloud, a picture of a funnel cloud that was taken a few minutes before the tornado picture I showed a few slides back. And again, it's going to be a fairly prominent feature. It's not just some stray piece of cloud. It's right underneath the wall cloud. Very smooth appearance, very pointy like this. It's going to be an obvious feature. So what are some signs that tornado threat may be increasing? One could be that the inflow winds are increasing. I remember being on many storm chases, but one in particular that comes to example is back in 2016, chasing in the Texas Panhandle and having a strengthening supercell with very strong 35-40 mile per hour winds, blowing right into the updraft towards the wall cloud, and it did eventually produce a tornado. So not just the sights, but also notice what is the wind doing? Is it blowing into the updraft or out of the updraft towards where you're looking? So that can actually be quite telling. If you have the wall cloud or the funnel cloud is rotating strongly, this will often precede tornado development. Or the updraft base is becoming increasingly circular. You're just getting a better defined, more crisp updraft under the thunderstorm. Okay, so here we have a video on tornado formation. So this is a look at a strongly rotating thunderstorm somewhere, it looks like out in the Texas Panhandle or High Plains. But anyhow, you can see this is the underside of the wall cloud here with a very prominent funnel cloud. And this is what I say whenever I keep saying it's a prominent feature. This is not just some, I should say a true funnel cloud is not just some ragged piece of cloud, but rather it's going to be something very pronounced, strongly rotating and right underneath the wall cloud. So we'll let this video keep going here. You see very quickly the funnel starts to lower towards the ground, and then boom, just like that, we have a tornado. Very short-lived, but you can see how quickly these can develop when you have this strong of a rotating wall cloud, strongly rotating funnel cloud. So here's another picture right here, and this is kind of like that first one where it doesn't look like the funnel is all the way to the ground, but if you look underneath the funnel, notice the debris cloud being kicked up. Right there. So that's called the condensation funnel right there, and then there's the debris cloud, and that's the giveaway that this is actually a tornado and not just a funnel cloud. So one of the common imposters that gets reported as a tornado or a funnel cloud is actually what we call a scud cloud. In the previous pictures you saw of the funnels, I kept pointing out that they're very prominent features. These look very ragged on here. They're not really attached to any kind of wall cloud here. So this is not a funnel cloud, this is just scud cloud right here. Again, there's no wall cloud. It's also in the outflow or downdraft region. This is rain falling behind the foreground here. They'll often have a ragged appearance, and then if you look underneath it, there's no debris cloud at ground level. So that's how we know that this is not a tornado or even a funnel cloud. So this looks like it could be a tornado here. We have what appears to be funnel or a cloud or something like this, some kind of cloud material that appears to be in contact with the ground, but it's a bit far off right now. It's almost more of a silhouette. We're not close, you can't really confirm any kind of debris cloud. So if we get a little bit closer, we can actually see that this is not a tornado and is in fact a wall cloud. So just keep in mind that you cannot be 100% confident until you can confirm contact with the ground and the presence of a debris cloud. Because remember, the definition is a violently rotating column of air in contact with the ground. So if you do have a violently rotating column of air, you're going to see at least dust and light debris getting kicked up. So going on to supercells, I've used this word a few times, and this is what we tend to focus on, these supercell thunderstorms here. And this is a really good picture of what one looks like, but we'll dive in and look at a little bit more of exactly what a supercell is and how to identify features associated with them. A supercell, by definition, is a thunderstorm with a persistent rotating updraft. About 1 in 5 of them produce tornadoes. But most of our strong to violent, that's EF2 or stronger tornadoes, come from supercells. I like to put it this way. Not all supercells produce tornadoes, but most tornadoes come from supercells. Supercells are certainly responsible for your stronger, higher-end tornadoes. And they're also capable of producing very large hail. The largest hailstone recorded in our region was 5 1/4 inch in diameter in Wiley, Texas, back in April of 2016. And they can also produce damaging wind gusts in excess of 70 miles per hour. So some of the largest hail and strongest tornadoes come from supercells. That's when we're going to focus on these a lot, because these are bad news if you see them in your area. So some basics on supercells. We like to identify the sides or the locations within a supercell as the flanks. So here's kind of what a supercell looks like if you look at it on radar. This is what we call a hook echo on here because of its hook shape appearance. So let's say this supercell is kind of moving a little north of due east, kind of east-northeast, which is pretty common direction of movement in our neck of the woods. So the flanks are defined as where you are relative to the movement of the supercell. To the left is the left flank, to the right is the right flank, ahead of it is the forward flank, and behind it's the rear flank. Pretty simple stuff here. And I point this out because we're going to use some of this terminology later, and this is a bit better of a way to discuss them too as the left side or right side, or the north or south, because not all supercells move in the same direction. Especially in the winter time around here, we can get supercells that move almost due north. And then we'll also talk about, we have what we call the forward flank downdraft. This is where all the heavy rain and large hail is falling, and that is not where you want to drive your new Mercedes. And then this area, right here at the tip of the hook, is what I like to call the tornado action area. It goes by many names. I've heard it called the vault, the bear's cage, the core, the mesocyclone. I like to just call it the tornado action area because if there's going to be a tornado, that's the spot it's going to be. So here's our little diagram again, the upper right hand corner. The star is where the photographer was standing, and the little yellow triangle is the field of view. So in this case, the photographer is standing in the right flank of it. Supercell is moving from the lower left to the upper right, so he or she is to the right of motion, so the right flank, looking back towards it. So this is a good view. They're taking it, I believe this was taken near Stillwater, Oklahoma, and so they have a nice high perspective of it, so you can see quite well. Here's where the updraft is, which is immediately in front of the photographer in this case. And one of the ways you can tell this is the updraft is notice you don't see much in the way of rain or hail falling out of this because the air is rising up here and is actually suspending rain and hail up above the ground. But as they say, what goes up must come down, and it's all coming down over here. This really dark area, this is where the hail and the rain is falling out of the storm. But up here in the updraft, this is the defining characteristic of a supercell. It's called a mesocyclone, and it's often given by this kind of bell-shaped appearance, like you see here, often very smooth, and that's the rotating part of the thunderstorm. So ways to differentiate between the updraft and downdraft. The updraft is where air is flowing towards and into the thunderstorm. Stronger the updraft can lead for a threat for large hail. Tornadoes, wall clouds, and mesocyclones are generally going to be occurring in this region of the supercell. It's often indicated by a rain-free base, and I'll have some more pictures of what that looks like as we go on. Conversely, the downdraft is where air is flowing out of and away from the thunderstorm. A strong downdraft will lead to a threat for damaging winds and is indicated by a region of heavy precipitation and cooler air. So if you have air blowing out of the storm into your face and there is rain and hail falling, you're in the downdraft. If you have warm air blowing into the storm and generally free of rain and hail, you're in the updraft. So I used this word a couple of slides back, the mesocyclone. The mesocyclone is a storm scale size phenomenon. It's usually 2 to 6 miles in diameter. And this is where the rotation of the thunderstorm is. It originates in the mid-levels, a few thousand feet above the ground, or I should say several thousand feet above the ground. And the thunderstorm is the defining characteristic of a supercell. There must be a mesocyclone present, which is the area of rotation, for it to even be considered a supercell. Then here's the wall cloud again. Talked about this earlier. But a wall cloud is an abrupt and pronounced cloud lowering found immediately beneath the mesocyclone. It's going to be in the updraft region of the thunderstorm, and again, it's an obvious feature. It's not going to be some small piece of cloud where you have to think about it, is it a wall cloud or not? It's going to stand out to you. And if that wall cloud is rotating, your tornado threat is likely increasing. So some more supercell basics. We have, let's talk about the motion of them. In this part of the country, in north and central Texas, most supercells are moving from southwest to northeast. They can be a little bit more southerly to more northerly, or a little more due west to due east, but generally southwest to northeast. And so the best view of the supercell is always going to be to the right of its motion. So it's usually going to be to the south or southeast. So going back to this diagram with a little more detail on it now, talking about the supercell structure. So we have the supercell, it's moving from southwest to northeast. You have the tornado action area, which is at the tip of the hook. Some areas of it, we talked about this earlier, you have the forward flank downdraft, which is where the hail and rain is falling. And then behind the tornado action area, you have the rear flank downdraft, where you can get very strong winds in here sometimes. 60, 70 mile per hour winds are not uncommon here. And so this is going to be where your best view is of this supercell, from one of these north-south roads here. Because in this case, the supercell is going to move safely to your north, like this, so you can be set up shop on one of these roads, and you'll have a nice view of the tornado action area to your northwest in this case. And if this thing starts to move, because sometimes they do turn, let's say it's moving from southwest to northeast and starts turning more due east, you can just quickly evacuate to the south on one of these roads to get out of its way. But this is your danger zone here, because this is where, right in the path of the motion of the supercell, this is where all the hail and rain's going to fall. Tornado could track through here, so that's not where you want to be. So here's another view of it. This photographer is standing immediately to the right of the tornado action area. And this is kind of what it might look like if you are in this location. You're going to have your outflow stratus or shelf cloud. This is wrapping around the back side of the supercell on the diagram here. Then you'll have the inflow stratus, which is this smoother looking cloud right here. This is where the air is flowing into the supercell. Sometimes you might have a little tail cloud that's down low like this, and this is just cloud material that's feeding into the updraft of the storm. And then here's your wall cloud kind of tucked up underneath this shelf cloud. It's this more pronounced lowering right in here. And that's going to be right again at the tip of the hook echo. And if you're going to get a tornado, that's going to be the spot to look. So this is a great view. It's starting to get a little bit in front of them, but you get the idea. This is what you're going to be looking at from the right side. You'll have a nice overview of all the action right here. So here's another picture, again, for a photographer standing to the right and in front of the supercell. Right here, you have the clear skies. This is that rain-free base I was talking about. This is where the air is flowing up and into the supercell thunderstorm right here. So you get these clear skies because you don't have any precipitation falling out. Meanwhile, off here to the right, notice how dark it is. This is where all the heavy rain and hail are falling. This is the downdraft of the supercell. So again, just more examples. I had this photo up earlier, but here it is again. There's the rain-free base. Nice and dry underneath here because you have, again, the air rising up and suspending any raindrops and hailstones up into the atmosphere. There's your wall cloud. That's this feature. And then your precipitation downdraft are going to be off screen to the right from this perspective. But let's talk about another imposter, the shelf cloud. These get reported as wall clouds all the time, and they can be quite intimidating looking if you see one of these coming. But they're often going to be associated with the outflow portion of the storm. So on the far forward flank of this, where you have the leading edge of the outflow on here. The tornado threat is very low at this, but there can be a damaging wind threat. Another common location for these is on the leading edge of a squall line. And one way you can tell is they have this very elongated appearance. They go from horizon to horizon most of the time. Unlike a wall cloud, which is a more compact area that's well defined. You can also see the rain falling out underneath it. This is in the downdraft portion of the storm. So these are all clues to look for. If you think you might be looking at a wall cloud, is if it has this big elongated appearance with rain falling immediately underneath it, it's actually probably a shelf cloud. And a shelf cloud does not need to be reported to us because they don't really indicate any necessarily pending severe weather threat. Now, they can be associated with high winds sometimes, but not necessarily. They often come through and you hardly get any wind at all. So, again, we don't need shelf clouds reported to us. Let's shift gears a little bit and talk about hail now. While tornadoes get a lot of the attention here, hail can be quite costly. If you've been unfortunate enough to get your car stuck in hail or your roof, you know all about this. So these are really good pictures of hail here of how to report it to us. Next to objects of known size. Here I can quickly look up what's the width of a $1 bill. This is even better next to a tape measure or a ruler, something like that. We one time had someone send us a picture of digital calipers on here with centimeters for the reading on it. You don't have to be that specific, but more power to you if you have something like that. But actually inches is fine. We are scientists, but we use imperial units for this, so inches, we don't need centimeters or millimeters or anything like that. This is another common one, is next to a coin here, right here. So you can tell it's a little bigger than quarter size hail. So that is actually severe hail. It's larger than an inch in diameter. What we ask that you don't do is tell us the marbles size hail, because marbles come in all different sizes. You know, you can have the larger shooter marbles to the smaller ones like this. So stick to objects that have a standard size. And here's a good example of that is, and you can find charts like this online that have objects of known size on it. For example, a penny, a nickel, a quarter, baseballs. You know, I can quickly look up what's the diameter of an MLB regulation baseball. Yes, I know grapefruits can come in slightly different sizes, but if it's grapefruit size hail, I'm not going to really split hairs over is it 3.75 or 4.25. I just know it's really big hail if you report grapefruit size hail to me. So here's a little pop quiz. Let's say we have hail of all different sizes in here. I mean, we have some smaller ones, we have some bigger ones in here. What do you think you should report when there's many different hail sizes? Would you report the smallest, the average, or the largest one here? Well, what we want to know is the largest that you see in here. And it's hard to tell exactly how big these are because we're not next to an object of known size, perhaps around quarter size hail or so, but that's what we want to know is tell us what the largest is. I mean, we often get reports where they'll say mostly dimes with a few nickels. We're going to enter it in our log as nickel-sized hail. But that's what we want to make sure we know is tell us what the largest hailstone size you see is. So here's another one. Let's say you have an oblong or spiky hailstone like this one here. How do you measure that? Would you use the shortest length? Maybe down here, would you use the average length, kind of maybe use the middle part, or would you use the longest length across the hailstone? Well, what we want to know, kind of similar to that last one, is we want to know the longest length of it. So I don't know if anyone wants to venture any guesses of how large this was, but if I put the background on, yes, this is a 3, this is the 11-inch, this is an 8-inch diameter hailstone that fell near the town of Vivian, South Dakota a few years ago and actually holds the record for the largest hailstone ever measured. And this did fall from a supercell thunderstorm. So a great report for hail sounds something like this. I'm a train spotter and would like to report approximately golf ball size hail at the corner of North MLK Boulevard and Herring Avenue in Waco at 3:15 p.m. A not so good report is something like this. Big hail doesn't tell me anything. I grew up in South Louisiana and did not see hail at all until I moved to Oklahoma at one time, and so the first hail I ever saw was about the size of dimes, and it was the largest hail I'd ever seen. I was in for a treat. So again, be specific on how big it is. And also a few minutes ago, how many is a few minutes ago? Is that 5 minutes, 10 minutes, 1 minute? Like they give us the exact time. You could even say 5 minutes ago, something like that. Also, Waco is a big place, so be specific where in Waco. But we want to know the time, the location, the magnitude. Again, that's how big is it. Is it measured or estimated? You're telling me approximately golf ball size, so I know you're estimating it versus, say, sending me a picture of the ruler. So that's what we want to know there. So then straight line winds. We talk about these a lot around here because there'll be a lot of people that think they see tornado damage in terms of straight line wind damage. And straight line winds are something that we really like to stress is how severe they can really be because they can produce damage similar to tornadoes sometimes and should be treated with a lot of caution because they can produce some rather severe damage. So some common sources include squall lines, such as this one. This is what it might look like on radar, where you'll have a jet of strong winds several thousand feet above the ground, and then it encounters a strong downdraft at the leading edge of these storms, which will bring it down to the surface right here. And what you'll end up getting is these kind of sporadic pockets of enhanced wind speed. So that's one of the ways we can tell if something is straight line winds versus a tornado. A lot of times as a tornado, when we do a damage survey, we tend to find, you know, kind of a concentrated path where we can easily connect the dots of all the damage. Versus straight line winds, you'll find these kind of sporadic pockets that don't really follow any rhyme or reason. It's just kind of, like I said, sporadic areas of high winds. Supercells, though, while we tend to focus on them for tornadoes and hail, can in fact produce some strong outflow winds around the periphery of it that can exceed 70 miles per hour. Typically in the forward flank, but also in the rear flank, can produce some very high winds. So if you're out here to the right of it and the supercell is coming past you, be on the lookout for this rear flank because you can get some high winds out of that. And then more commonly in the summer, downbursts, aka microbursts, are what they're called sometimes. And if any of you remember or have read about Delta Airlines Flight 191, the plane crash that occurred at DFW Airport back in the 1980s, that was actually brought down by a downburst here. And these can produce very high winds. I've even seen where in rare cases they can produce nearly 100-mile-per-hour winds. So all of these sources of straight line winds can be very dangerous and produce some very impressive winds. So how would you report winds? Well, you can estimate them, and what they might look like is from 30 to 50 miles per hour is your typical thunderstorm winds. These are the kind of winds you see from most thunderstorms around here, where it gets a little gusty, but nothing too out of control. You will probably see this at your house every year, sometimes multiple times a year if we have a lot of thunderstorms. Maybe you get some twigs and branches broken off, might displace your trampoline, blow over your lawn furniture, stuff like that. You know, nothing too bad. This is less common though once you start getting over 60 miles per hour. This is officially when you're in severe criteria here. You might see that at your house maybe once every several years. It's even in North Texas is fairly rare to see these winds at a fixed location. And I stress that because obviously if you're out mobile storm chasing, you'll see these more often. But you know, if you're just reporting from your house or place of business, they're going to be less common. At these speeds, this is where roof damage begins to occur, as well as more notable tree damage, uprooting of smaller diseased trees. I grew up in South Louisiana, and even this is starting to get to around the territory of, say, a Category 1 hurricane. And having been in a Category 1 hurricane, you'll actually start seeing not extensive roof damage, but you'll get, you know, some of the shingles are removed, some trees can get uprooted, and all. These kind of winds over 80 miles per hour, getting up even over 100, this is rare. You may never see these kind of winds in your lifetime, and this is starting to get into well into strong hurricane territory at this point. You're going to get damage consistent with a tornado, extensive roof damage, structural damage, and even healthy trees can be blown down or uprooted. And again, unless you're in a hurricane or a very rare, very strong straight line wind event, you may never see these. These are, and if you do see it, it'll be one of the most impressive things you see in your life. It is quite a sight to behold. So just some videos of what some of this might look like is so that's kind of what lower end thunderstorm winds look like. You know, typical thunderstorm raining pretty hard. But notice the visibility in there. You can still see the houses across the street just fine, even with all the rain falling, and so on. So let's go a little bit higher now. All right, so that's getting close to the threshold of severe. You have some twigs and branches starting to break off. It's hard to see, the end of the driveway at this. Here's another video. This is a little over 60 miles per hour. That was actually from a downburst in the summertime. I believe it was filmed in Irving, Texas there, and the top half of a tree came out as that went through. All right, now this is getting into some pretty intense straight line winds now. And that right there is getting, almost, it is hurricane force winds. Almost no visibility. At some point in the video, you saw the tree branch fly across the screen. Back it up if you missed it. And you notice that the trees that were out there were struggling to stand. And that seems to be about as high as winds can get most of the time. Or is it? Let's see what about 110 miles per hour might look like. So that video was filmed during Hurricane Michael, which was actually a Category 5 hurricane that made landfall in Florida in October of 2018. I don't think they were right in the Category 5 winds, but it was pretty intense. And notice if you were standing in that kind of wind, well, you wouldn't be standing for very long. There's large debris blowing through. So now you have kind of a visual idea of what these winds look like. So just kind of what some damage looks like, fences, trampolines, Bradford pear trees. It doesn't take much wind to displace things like that. Closer to 50, you might get a large tree like this, but if you look close at this tree, it doesn't look super healthy here. Now, of course, if you're the homeowner here, this is still quite a mess to clean up, not to downplay it, but notice the other tree and the fence right here look okay. So it's probably about 50 mile per hour winds. Over 60 miles an hour, you start getting some roof damage. You see this tree is uprooted in the picture. Up close to 70 miles an hour, again, you get some roof damage there. The structure itself looks okay, but like I said, you start getting the roof damage around there. Getting close into the 80, 90 mile per hour range. I believe this was a bus or a trailer sometime was rolled over multiple times and destroyed. And then approaching 100 miles per hour. And actually this last picture here, this was from straight line winds. Did this. So again, to stress the point, of straight line winds can produce some very severe damage. So a great report might look something like this. I'm a trained spotter and would like to report numerous 1 to 3 inch diameter tree limbs broken. No other damage noted right now. I'm located 5 miles north of Axel on 317, and this happened around 3:45 p.m. I've tweeted a photo to you. A not so good report would just be something like crazy winds. Okay. But again, we want the time, the location, the magnitude, is it measured or estimated, and then is there any damage with it. But a note on estimating winds. Visually estimating the wind speeds can be very difficult, even for a meteorologist. Some of those pictures we showed you earlier, they even caused a lot of discussion amongst us at the office. So if you have pictures or a description of damage, that can be easier and a lot more useful for us. Again, just tell us what kind of damage you have, because you'd be amazed how many times we get a report where someone will say 70 mile per hour winds, and we'll ask them, what kind of damage do you see? And they'll say no damage. If you have 70 mile per hour winds, there's going to be damage. So maybe focus more on the damage than actually trying to estimate a particular wind speed, unless, of course, you have a weather station or something like that where you can directly measure the wind speed. So then moving on to flooding. Flooding can be overlooked a lot when severe weather or tornadoes are ongoing, but flood reporting is just as crucial to our mission. In fact, flooding claims more lives and causes more destruction than severe storms and tornadoes do. And even for hurricanes, inland flooding is the deadliest phenomenon associated with them. So flooding is very important to be reported to us. The most common report we receive is high water. That's kind of like reporting marble-sized hail. How high is high? So we'll talk about how to differentiate different types of flooding and how we like having flooding reported to us. So what we need to know, the elements of reporting flooding, are, first is the flood magnitude. How high is high? Is it ankle deep? Is it entering structures? Is it, in this case, it's up to 12 feet on a flood gauge here. So again, specific terms about how high is high. What's the frequency of it? How often does this happen? Is this the spot that floods every time it rains? Is it in a construction zone, flood-prone areas? Or is this, I've lived in such and such town for 10 years and I have never seen this flood even in heavy rain before? That's something very important. And we're going to ask you, if you call in to report any kind of flooding, we'll say, have you seen this area flood before? And then what's the behavior of the flood water? Is it standing water? That might just be from, okay, a lake or river has gotten full from repeated days on of heavy rains, or is this rushing water where something quickly rose up and is flooded out of its banks? So these are the elements we like to know when you're reporting flooding, in addition to the time, the location, and that kind of information. So you have flash flooding, which is defined as a rapid rise of swift-moving water resulting in a threat to life or property. Here's a picture from Hurricane Harvey where you can see water way up high on the stop sign here in a residential area. Cars stalled out on the road. So that's the kind of flooding. This is the kind of flooding we're talking about for a flash flood event. So the flood magnitude, it's going to be vehicles that are partially or completely submerged. The main roads are likely going to be impassable. And some inundation of commercial and residential structures is possible. True flash flooding shouldn't be very frequent. Spring of 2015 be an exception because it was so wet that spring that it reached a point where every time it was raining, flash flooding was occurring. So flooding got a lot more frequent, but typically it's a pretty rare event. And water is likely going to be moving swiftly, especially initially as you get a lot of runoff and, like I said, you get quick, fast-moving water. So a good flash flood report looks something like this. You're a trained weather spotter reporting flash flooding on McKinney Street on the east side of Denton. So there's the specific location. 2 to 3 feet of water rushing across the road near the Bell Avenue intersection. So you're telling me the magnitude and the behavior of the flood water. Water started rising around 8:20 and it's still rising at current time. I've lived here for 10 years. I've never seen anything like this. That last part is important because you're telling me this is pretty rare. I've emailed you a picture. That's a not so good report. Doesn't tell me anything. It tells me there's a lot of rain in Denton. So again, the time, the location, the magnitude, the behavior, and the frequency. These are all things we're looking for with reporting flooding. Then we have what we like to call common or minor flooding. Something like this. Stream is still in its banks, but it's over a low water crossing, so it's certainly going to be a nuisance to you. And it actually could be dangerous if you made a poor decision to drive through that. Or this. Again, it's potentially dangerous if you make a bad decision, but overall it's nothing too bad. So here's a good example. This actually at the time got reported to us as high water on Loop 12. Again, that's not a very good report. How about this? Loop 12 at I-30, so its specific location, is closed due to around a foot of standing water beneath the overpass. This is certainly going to be a headache for commuters, but overall it's not life-threatening unless, again, a poor decision was made. Another example. The flood magnitude for common minor flooding, it tends to be, ankle deep, maybe curb-to-curb flooding. And it can even partially submerge vehicles if it's a low spot or area of poor drainage, under an underpass, construction zone, under a railroad bridge. Those are good examples. Low-lying construction areas can flood even with marginal rain rates, so minor flooding can actually occur pretty frequently. This type of flooding, this is what we talk about when it's the kind of flooding that occurs every time it rains. And the water tends to be standing or maybe moving slowly, so nothing, again, nothing too dangerous generally speaking. How should you report this? You'd like to report minor road flooding. Current time, 6 to 12 inches of standing water on Highway 84 beneath I-35. It's causing the road to become impassable. This location floods fairly often when there's heavy rain. A not so good report is high water on Highway 84 in Waco. So again, we want the time, current time, location, Highway 84 beneath the I-35 overpass northeast of Waco. The magnitude, 6 to 12 inches. The behavior, standing water. And the frequency, the location floods fairly often when there's very heavy rain. So is this flooding? No, this is not flooding. The first one is just construction zone. The second picture, this is water still in a creek. I mean, it's pretty high here, but it's still well within the banks, and the drainage system is doing as it's designed to do. So this is what we like to just call ponding of water, especially the first case. It's no threat to life or property, and you do not need to report this to us. So again, it's kind of a spectrum here. So ponding occurs every time it rains. Construction zones in particular are prone. Then you have the common or minor flooding, can occur a few times a year. And again, it can't be dangerous if a bad decision is made. So it's not to say that it's not noteworthy or not unimportant, but generally, unless a bad decision is made, it's going to be fairly innocuous flooding. And then you have flash flooding, which is going to be infrequent, and you may need to take action to protect yourself. The common minor flooding, this is what we usually, when we issue a flood advisory, this is what we're talking about, whereas a flash flood warning is up here on the high end of the spectrum. Way off the charts here is, you might have seen used a few times, the term flash flood emergency. That's for events like Hurricane Harvey, where there is widespread catastrophic flash flooding underway, where this is above and beyond evacuate low areas and stay off the road. This is areas that do not or may have even never flooded, could be in danger. So how do you report all this stuff to us? Amateur radio is still a great way to report stuff to us. Aries and Racy serve many groups. For more information, you can go to the website wx5fwd.org. By phone at this 1-800 number. Now, if you call the 1-800 number, you're going to get a voicemail answering machine. Don't be discouraged by that. Just leave your report. Again, give us the time, the magnitude, the location, and so on for that. And the box for this is actually right in our operations area. Rest assured, we're getting your report. If you feel so compelled, you can leave your number, and we may follow up. We don't usually, but if we're particularly interested, we might. So that's a great way. Social media is a really good way to send us pictures, but it may not be seen in real time. Especially if we have an event, say, going to the Metroplex. I remember one event in particular where we had large hail going through Denton and Collin counties, and we're getting swarmed with pictures on social media, and we're very grateful for all the pictures, but the point is if you have something really important on there, we may not see it in real time. So phone or amateur radio might be more important in real time. And there's the MPing app. I'll show screenshots of this in just a moment, and it's a really good way to report severe weather and even winter weather. So here's what MPing looks like. It's available for iPhone and Android. Pull up the screen like this. It'll use your location. You select your report type. So here's an example of things you can report. Let's say you do precipitation type. You can pick snow or mixed rain and snow and so on, and submit your report like that, and it goes straight to our office. That's excellent. It doesn't give you any way to give a lot of detail or anything, so if you have more details you'd like to report, use the other things. But this is a quick way to just give a real quick report. Maybe if you don't have time to pick up the phone or something like this, it'll still get the job done. Now I have to talk about what not to report. First is what you see on radar or satellite. We get this a lot, actually, of people actually tweeting us pictures of radar saying, did you see whatever, or whatever we're looking at radar. Heavy rain or rainfall rates. We often get reports of an instantaneous rainfall rate of 8 inches per hour. And our follow-up question is, how long has it been doing that? Oh, for 2 minutes. You know, focus more on flash flooding. Scary looking clouds, these are the scud clouds, the shelf clouds, basically the imposters I mentioned. And then lightning. Now, if lightning has resulted in injuries or significant structural damage, we might want to hear about it. Obviously, if it has started a fire, contact your emergency officials. But lightning, just, you know, that there's a lot of lightning or that there's cloud to ground lightning, we don't need reports of that. So again, only if it's resulted in injuries or significant damage. So just some more examples of what good reports look like. What are you reporting? What time did it occur? Where did it occur? For these kind of things. Bad reports, things like reporting a lowering. What is that? Technically, fog could be considered a lowering. What your radar app says, or just things like it's raining hard and there's a lot of lightning. These are things we don't need to know. They don't tell us anything, or they're things we can just see with remote sensing, such as what you see on radar. So I'll close out here with a word on spotter safety. So some good safety tips. If you're mobile, have 2 people in the vehicle, because the person driving needs to just focus on the road, not looking at radar or talking on the radio while trying to drive. Not safe. Stay on the paved roads. Typically when we have severe and thunderstorms, the unpaved roads can get wet and become impassable. The last thing you want is to be stuck on a dirt road somewhere when you have a tornado bearing down on you. If you do stop to take pictures or make a report, pull completely off the roadway. Of course, being respectful for private property. Keep your vehicle running. Because when you have that tornado or the large hail bearing down on you, wouldn't you know, that's the one time your car is not going to start. So make sure to keep the vehicle running. Always have an escape route, so stay situationally aware, know where you are, and have a way to get out if you need to. Watch for flooding and lightning. Have access to shelter if you're a point spotter. And then keep your wits about you. You know, think yourself through the situation. Don't panic if something scary does start to happen. And of course, beware of traffic and obey traffic laws. Unfortunately, there have been chasers injured or even killed because of either running a stop sign or driving too fast or whatever. So please make sure that you're obeying the traffic laws and being aware of your surroundings. Specifically at flash flooding, we always like to say turn around, don't drown, because just a couple of feet will float most vehicles, including, yes, your large pickup truck or your SUV. Only 12 inches of moving water can knock a person off of balance, even less for children. So stay away from creeks and ditches, and then be especially cautious at night. A lot of flash flooding fatalities occur at night when people drive into water of unknown depths. So for hail, I love the picture on the right here because it is a NOAA research vehicle that had a bad encounter with large hail. Avoid core punching, which is where you drive through the forward flank in an attempt to get to the tornado action area. That's a good way to ruin your car. Stay inside your vehicle or building, and my personal favorite is don't try to measure hail while it is still falling. You would be surprised. For lightning safety, move inside at the first thunder. If you hear thunder, you're close enough for lightning to pose a threat. You want to be inside of a strong grounded building or in a car with the windows rolled up. And that's assuming you're not touching anything connected or exposed to the outside of your car, such as your ham radio antenna. And then you should stay in shelter until 30 minutes after the last thunder. So we'll kind of close this out by going through some examples here to see what we learned. So here's an example, and what are we looking at here? This is a shelf cloud, and how we know this is a shelf cloud here is, again, it's kind of this elongated horizon to horizon. Here's rain and perhaps some hail falling out of this. Also, this very turbulent look, not very smooth looking. So those are some clues that this is a shelf cloud. This is not a wall cloud here. And should you report a shelf cloud? The answer is no. Often shelf clouds can be reported with high winds, but not necessarily. Often they come through and nothing happens. Sometimes they come through and you get really high winds. So stand by, be on the lookout for the possibility of high winds, but the shelf cloud by itself does not need to be reported to us. This here is some lightning, including a cloud-to-ground lightning strike on the left side of the frame here, and quite a bit of lightning. But we do not need lightning reported to us, again, unless there are injuries or significant damage. Just the lightning by itself does not need to be reported. So would this be considered flooding? This is not flooding here. This is just minor ponding of water, and this does not need to be reported to us. What is this here? It's actually a supercell, the wall cloud. Wall cloud is the feature right here, again, right underneath the updraft mesocyclone portion of the supercell. Should you report the wall cloud? Is it persistent? Is it rotating? Is it organized? Absolutely report it. Wall clouds are a sign of that tornado threat could be increasing, so that's something we would like reported to us. So this is a supercell on radar. In this case, this is kind of what they look like. There's the hook echo. Here's the forward flank downdraft where all the rain and hail is falling. But should you report that? No, we do not need to know what you're seeing on radar. We're looking at radar already. That's not something, I mean, it's a remote sensing thing. Again, focus on things that we cannot see through remote means. So here's a video of some thunderstorm winds here, and I want you to watch this video for a moment and think to yourself, would this be severe criteria winds, and should these be reported to us at the Weather Service? So again, here's the question. How strong are these winds? Are they severe? These winds are maybe 35 to 40 mile per hour tops, not even close to severe. And should you report this? No. We do not need to know winds of only 35 to 40. We generally want it to be 50 or higher, or there's significant wind damage. But of course, you should always monitor for intensification. Is this hail severe? Only one way to find out. Measure it after it has stopped falling. Should you report it? If it's greater than 3/4 of an inch, which eyeballing it here probably is. What's that? This is a funnel cloud. It's underneath a wall cloud in a rain-free base. Got a nice smooth appearance to it on there. Should you report that? Yes, absolutely. This here, though, is just a scud cloud. It's in front of a downdraft portion of the storm, more ragged in appearance, and that does not need to be reported. And then finally, I hope we can identify that this is a tornado. You have the funnel, large debris cloud underneath it here, and absolutely report that to us. So this concludes the end of this online SKYWARN presentation. Our contact information is there in the upper right, our public phone number, our Twitter handle, and an email address where you can send us any questions, comments, concerns, or compliments you have about this presentation. And then I'll close by just saying if you have any photos or videos that we can use in future SKYWARN talks, you can email them to that same email address. Thank you for watching.